Today, we're going to look at a totally different way of thinking about language, something called head-driven phrase structure grammar, or HSPG. It came about in the mid-'80s, and it's basically a complete rethink of how sentences work, one that's built with the kind of logic you'd find in a computer program.
So let me start with a question for you. What if putting a sentence together wasn't about, moving pieces all over the place? What if it was more like solving a really satisfying logic puzzle, where every single piece has to click into place perfectly according to a set of rules? This question, well, it gets right to the very core of what makes HSPG so special.
So on one side, you have the approach you've probably heard of, the one that's often tied to Chomsky. You start with a kind of deep structure, and then you move parts around. But HSPG, on the other side, it just throws that whole idea out the window. It's what we call a constraint-based system, and it has just one level. What you see is what you get. A sentence is good to go only if every piece fits perfectly from the get-go. No hidden steps and absolutely no movement.
Now, to really appreciate HPSG, we first got to understand the idea it's pushing back against. So let's do a quick refresher on that traditional view, grammar as a series of transformations.
The big concept here is movement. So for example, to get a question like, what did you see? This series suggests you'd actually start with something like, you did see what? Then a special rule kicks in and moves the word what right to the front. It's a process with multiple steps, generating the final sentence.
Okay, so now let's bring in the challenger. HPSG comes to the table with a totally different philosophy, one that is completely surface-driven.
HSPSG is what linguists call monostratal. That's a fancy word, but it just means it works with a single layer of structure. There's no deep structure, no transformations, and, you guessed it, no movement. The sentence, "What did you see?" is analyzed exactly as you see and hear it. Everything is right there on the surface. No hidden steps involved.
And the reason it can do this is because HPSG is constraint-based. The best way to think about it is like building a high-precision model airplane. A sentence is grammatically correct only if every single piece, every word, fits together perfectly with its neighbors, all according to a super strict set of rules or constraints. If just one little piece doesn't fit, if one constraint is violated, the whole thing just doesn't work. It's not about modifying things. A sentence is either valid from the start or it's not.
So how in the world does this constraint system actually work? Well, it all comes down to seeing words not just as, well, words, but as these incredibly rich little packages of information. Let's dive into this idea of language as feature sets.
The absolute fundamental building block in HPSG is something called a feature structure. You can just think of it as a super detailed spec sheet for any word or phrase. It's just a list of its properties, which we call attributes, and their specific values.
Before we get lost in grammar, let's use a really simple example. We could describe a person using one of these charts, called an AVM. The attributes are things like first name and birthday, and each one has a specific value. See? It's just a really neat, organized way to store information.
Okay, now here's where it gets really cool. We apply that exact same logic to a word like walks. It's not just a word. It's a feature structure that carries its own little instruction manual. It knows it's a verb, and it actually demands a subject that is third person and singular. All of that grammatical information is packed right into the word itself.
So, sentences get built by combining these feature structures, and the process is called unification. And this is the kicker, two structures can only unify if their features are compatible. They can't clash. This is such a brilliant way to explain why books sounds so wrong. The word has a feature that says number, singular, but books has a feature that says number, plural. Bam! The features clash, unification fails, and the phrase is ungrammatical. It's just that elegant.
This whole system of these information-packed words is really governed by a few incredibly elegant principles that just make it all click. So let's look at how heads, the lexicon, and constraints all work together.
First up is the head feature principle. This sounds technical, but it just means that a phrase gets its basic identity from its most important word, the head. So if the head word is a verb, the whole phrase acts like a verb phrase. The phrase basically inherits its personality from its head.
Let's see this in action, right? In the phrase, drinks milk, the verb drinks is clearly the head. So, because of that head feature principle, its core identity, the fact that it's a verb, flows right up to the parent node. And that's what defines the entire chunk drinks milk as a verb phrase. Simple as that. The phrase gets its identity from its most important part.
You know, I saw this quote from a Reddit user that just nails the whole HPSG philosophy. They said that because each word is this massively bigger package of information, the grammar itself doesn't need a ton of complicated rules or extra layers. All the smarts are packed into the words themselves, which makes the overall sentence structure way cleaner and simpler.
Okay, so this is all very clever, but you might be asking, so what? Why does all this technical stuff actually matter? Well, it matters because this formal, super precise system turns out to be incredibly useful in the real world. Let's see how. Yeah, HPSG isn't just some dusty academic theory. It's a real workhorse in the world of computational linguistics. Its precision makes it perfect for tough jobs like machine translation. It was used in Germany's big Verbomobile project, and for pulling structured data out of messy text, and even for powering those automated email and customer service systems we all interact with.
And honestly, the results really do speak for themselves. This number here is an F1 score. Just think of it like a grade on a report card for how well a program can understand a sentence. And a score of 95.84, which was achieved by an HPSG system back in 2019. That's not just a good grade. That is a state-of-the-art, top-of-the-class result on a really important industry benchmark. It just proves how powerful and precise this approach can be. And this success isn't just happening in a bubble. HPSG is supported by this amazing global ecosystem of tools and research. You've got initiatives like Delphin coordinating efforts to build these powerful grammars, which then get used by systems at major research centers all over the world, from Germany to Japan to Stanford. It's a huge collaborative effort.
So, let's just pull back for a second and wrap up the core philosophy here. What is the HPSG perspective, and what does it mean going forward?
The HPSG philosophy really boils down to three things. One, it's formal, which means its theories are so precise you can actually write code and test them. Two, it's data-driven, meaning it stays grounded in how people actually talk and write. And when you put that kind of formal precision together with real-world data, you end up with a system that is, by its very design, computationally practical. It's built to work with computers.
And this brings us to a final, pretty mind-bending thought. HPSG really shows us a world where linguistic theory and computer science aren't separate fields, they're deeply connected. So as AI gets more and more powerful, you've got to wonder, will these grammars that were designed for computers, will they eventually become the new standard for how we understand human language itself? It's a wild question to think about.